Okay, we're going to prove that the quadratic formula is actually what we say it is, which is quadratic formula. We usually see it right away in terms of what it is. We memorize this, but I don't want to do that. I don't want to memorize. I don't want to just look up this formula in a textbook. I want to understand it. It's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And why bother understanding it? Well, not only is it a mental exercise, and not only does it use and reveal other properties of numbers and math, but if you have a bad memory, it's really important to be able to reason your way through anything. And I guess even if you don't have a bad memory, it's really important that you can reason your way through something, even if it's nasty looking like this. And that's what we're going to do here. So let's reason our way through it. If f of x, or y, is ax squared plus bx plus c, how can we always solve for x? Well, we want f of x to be 0 or y to be 0. And then we can start. We want to solve for x at 0. So eventually I want to get x all by itself. So let me actually put my numbers on the right hand side here and leave my x's on the left, because eventually I would like to get something like this where the x's are on the left and the numbers are on the right. So this equals 0. I'm going to subtract c from both sides. I can move that number, and now I have ax squared plus bx, c minus c is 0, and 0 minus c is minus c. Well, I want to get x squared and x by itself eventually, so let me divide by a. That'll help me a little bit. So now I can get x squared by itself. A divided by a, or a times x squared divided by a, the two a's will undo each other. Those are inverse operations. So we get x squared plus b over a times x. That's the same thing as b times x over a, just written a different way, equals minus c over a. I want to give myself a little bit of room here, because this is where completing the square comes in handy. And that's so interesting to me, because I feel like at this point I would be stuck if I couldn't complete the square. And I'm going to do that. I'm going to complete the square so I can factor all this and take my x squared and x and rewrite it so that there's just an x, and that's nice. So what do? Well, to complete the square, we take b over a and we divide that by 2, which equals b over 2a. And then we take b over 2a and we square it. We multiply it by itself. And I'm just going to leave it like that for now. So we have plus b over 2a squared. And one point that might throw you off when you're completing a square is that if you're adding this to one side, the equation has to stay balanced. So you add this to both sides. So now the equation is still balanced. And now, even though we have this that looks like a mess, we are in a much nicer position, because now we've created this quadratic, which can be factored very nicely into x plus b over 2a. That squared. And that's the idea of completing the square, if you remember. It's x plus the square root of the constant term here. So that's just x plus b over 2a. That squared equals minus c over a plus b over 2a squared. And although we have all this written out so far, we are right on the brink of finishing the quadratic formula. You can almost see it. So I'm going to need a new page, though, to finish this. Okay, so we're up to this. What do we do next? Well, just like we do when we have a variable squared, if you want to know what it is, you take the square root. So let's take the square root of both sides. X plus b over 2a squared. The square root of that will equal the square root of minus c over a plus b over 2a squared. Okay, what can we do here? Well, the square root of x plus b over 2a squared is just, well, the square root of anything squared is going to be that term. So this is going to be x plus b over 2a. And look at that. Even before we go any further, look what we just did. Right now we have just x all by itself on one side of the equation. So now it doesn't matter how nasty this stuff gets, we've done it. We have x by itself. Almost by itself, excuse me. Okay, so what do we do next? Well, this is going to be equal to, we'll leave this over here for now, minus c over a plus, and then b over 2a squared. What is the next step? Well, get x by itself. So subtract b over 2a from both sides. So minus b over 2a, and then minus b over 2a from both sides. We're almost there. B over 2a minus b over 2a is 0. So we have x equals the square root of minus c over a plus b over 2a squared minus b over 2a. And I'm going to start writing up here. Okay, now, well, we're actually, I don't know if you see it yet, we're like right there. So x equals, I'm going to put this in the front, so it becomes minus b over 2a plus the square root of minus c over a plus b over 2a squared. And all I did there was, instead of taking this term minus b over 2a, I'm saying negative b over 2a plus that term. Just switching in the terms. And now I'm going to combine the like terms inside the square root. So x equals negative b over 2a plus, well, what are we doing here? Well, c over a has to have the same denominator as this term. And let's distribute the squared. So it's b squared over 4a squared plus, well, I need to have c over a have the same denominator, and we just have a there, but we need 4a squared. So I'm going to multiply both numerator and denominator by 4a squared. So I get minus 4a. Excuse me, multiply the numerator and denominator by 4a. You already have an a down here. So that becomes 4a squared. This becomes minus 4a times c. And look at that, we're right there. So x equals minus b over 2a plus the square root of minus 4ac plus b squared. And then we have the same denominators, so it's all over 4a squared. Now we have minus b over 2a plus, in this case, we can switch the order, so it's b squared minus 4ac. Instead of minus 4ac plus b squared, we switch the order. And the square root, when you have the square root, I'm running out of room, I can write it over here. If you have the square root of something like 2 over 4, we'll say 9 over 16, what you can think of is the square root of 9 is 3, and the square root of 16 is 4. Now we don't know the square root of this upper term, right, because it's separated by subtraction. We're not sure how we got this. But 4a squared, we can take the square root of that, it's just 2a. And now we have x equals minus b over 2a plus this stuff over 2a, same denominator. So it's plus, and then b squared minus 4ac. But the idea is that the square root of this number could be positive or negative. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And that shows us eventually through all those steps we got this formula, and I hope you recognize it. It's the quadratic formula. Okay, I'm a little tired now, but I showed it, so I'm happy.